Hello friends, welcome back to our channel Aha Zindagi Edu-Care. On our channel, you will get online study materials related to maths and science from class 8 to 12. You may visit playlist section of our channel and as per your relevant courses, you may go to that section. Okay friends? Coming to the number system, in the last lecture of number system, we have seen what are natural numbers, whole numbers, integers. We have seen rational numbers, irrational numbers, and how we represent rational numbers and irrational numbers on a number line. Then we have seen the decimal expansion of rational number, and we came to the conclusion that a rational number, when expressed in a decimal expansion, will be either terminating or non-terminating recurring number. Okay. Today we are going to see the decimal expansion of a irrational number. Then we will see representing the real numbers on a number line and operations on real numbers. Okay, friends. So let's start from where we left in the last lecture. Those who have not seen the last lecture, please follow the link given in the description box so that you can easily understand this lecture. Okay, friends. So, in case of a irrational number, the decimal expansion of an irrational number is non-terminating, non-recurring. Okay, so it will not going to repeat like we have seen in case of rational numbers. After decimal, we get a block of repeating numbers or either it is terminating. So, in case of irrational numbers, it will be non-terminating and non-recurring. A number whose decimal expansion is non-terminating and non-recurring is irrational. Okay, so we see that decimal expansion of an irrational number of an irrational number is non-terminating and is non-terminating, non-recurring. Moreover, a number whose decimal expansion is non-terminating non-recurring is irrational. Okay, so decimal expansion will be non-terminating and non-recurring. If we see for an example, as we have seen, root 2 is an irrational number. In decimal form, if it is written, we may find this as 1.414213562370, and like that it will keep on going and it will not be terminating and even it will be non-recurring. Similarly, we know pi is an irrational number and its value is 3.14159265389793 and so on. It will also be non-terminating and non-recurring. So no block of numbers will keep on repeating. Okay, friends. As an approximation, sometimes we use pi as 22 by 7. As we see, 22 by 7 is a rational number and pi is irrational number. Okay, friends? But this is only an approximate value. It will not be equal to. So pi is not in actuality is equal to 7. It is approximate only. Approximate. Okay. So now we have seen how to find a rational number between two integers or some rational numbers in between two rational numbers. We have seen in our last lecture. Today we will see how to find an irrational number between two rational numbers. So we will first clean this. So if you have to find an irrational number between 1 by 7, which is a rational number, and 2 by 7. So how to do this? We will see 1 by 7 is a rational number with a recurring block. Okay. After decimal, it will can be expressed in decimal form as a non-terminating but recurring number. So it can be written as 0.142857 and then again this will repeat. So we write as recurring number. Similarly, if we see 2 by 7 can be expressed as twice into 1 by 7. Okay, and this we will multiply with the value of 1.7. So we will get 0.285714 and this will keep on repeating. Okay, friends. Now we have to find a irrational number between 1 by 7 and 2 by 7. As we know, an irrational number will be non-terminating and non-recurring. So can we find any number between these two? As we may notice, so we have to find a number between 0.1428 and 0.2857. Of course, we can find infinitely many such numbers. So one example or one irrational number can be taken as point. If we see 0.15, okay, we will take 0.15 which is more than 1.7. See, so 0.15 as it is irrational, so it will be non-terminating and non-recurring. So we will put 0.150, then again 15 we will repeat, and then we will put double zero, then 1500, 15 4 times 0, and so on. Okay, so it will be non-terminating and non-recurring. So this is an irrational number between 1 by 7 and 2 by 7. Next we will see how to represent real numbers on a number line. So if we take any number, suppose represent 2.665 on a number line. So what we have to do, see if we see one by one, this 2.665 we can notice that it will lie between 2 and 3, and since it is 2.6, so it will be between 2.5 and 3. Okay, so if we represent this, first we will make this as a number line, and only we are going to represent 2 and 3. Okay, so it will be 2.5. So now we can understand it will be more than 2.5 and less than 3. Now if we go to next decimal, so 2.66. So can we understand if we divide this into 5 equal divisions? 1, 2, 3, 4, 5. So it is your 2.6. This one is 2.6 and this is 2.7. Okay. So we can see after seeing this decimal after decimal second place, here also it is 6. So 0.66. So it will be less than 2.7. So we can understand that it will lie somewhere here 2.66. Okay. So 2.66 will be in between this. Next, we will divide this number line. We will take a larger scale. So if we take here 2.6 and here 2.7 and divide this into 10 equal parts. If we divide this into 10 equal parts, so it is your 2.5 and this is your 2.6. Okay, this is your 2.7. So our 2.665 will lie somewhere here. Sorry, this is 2.65 and this is your 2.66 and this is 2.67. Okay, so it is your 2 point, our number will lie somewhere here, but again we are not sure where. So again we will divide this into a larger scale and we can divide this into 2.66 and 2.67. So we will divide this in 10 equal parts. Okay, so 2.666 is this one, 2.661, 2.662, 2.663, 2.664 and this one will be 2.665. So in this way we can represent a real number on a number line. Okay friends. So next we will discuss operation on real numbers. So let's clean this. Operation on real numbers. As we have seen, in case of a rational number, commutative, associative, and distributive law are applicable for addition and multiplication. However, if we see for irrational numbers, we can check whether these rules are applicable or not. So, if we add two rational numbers, two irrational numbers, can we say that these rules are applicable? So, if we take root 6 plus minus of root 6, so if we see root 6 and root minus 6, it will be 0. In case of rational numbers, we have seen if we add two rational numbers, we will get another rational number. That is, two rational numbers are closed over addition, multiplication, and subtraction. But in case of irrational numbers, these are not closed under multiplication. Even if we multiply two irrational number root 3 into root 3, we will get a rational number. So these are not closed under addition, multiplication, and subtraction or division. Even root 5 by root 5, we can say it will be 1. So ratio or division of two rational numbers can be two irrational numbers can be rational number. So irrational numbers are not closed under addition, subtraction, multiplication and division. Okay. However, if we see commutative, associative, and distributive laws, so if we can write 2 plus root 3, it will be same as root 3 plus 2. So one rational irrational number plus this is if we take two irrational number, okay, root 3 plus root 2 can also be written as root 2 plus root 3. So two irrational numbers are distribute, sorry, this is commutative property. Okay, so irrational numbers commutative property is applicable. Then associative property, if we can see, okay, so associative property will be also be applicable for root 3 plus 1 plus root 2. Okay, root 3 plus 1 plus root 2. And similarly, distributive property is also applicable for irrational numbers. Okay, so we can know that commutative, associative, and distributive property are applicable for irrational numbers also. Okay, so we will clean this and we'll see some problem. Addition of two irrational numbers. So if we add a rational number and an irrational number, the resulting number will be irrational. Okay. Now, if we take a question, we have to find addition of 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So how we can add this? See, as we add in case of rational numbers, here also we can add like that only. So this is equal to 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. So we will take same irrational numbers or same, like root 2 is common, we will take root 2 common. So 2 plus 1, and again we will take root 3 common. So 5 minus 3. So it will be 3 root 2 plus 2 root 3. Okay. So this is addition of two irrational numbers. Similarly, if we have to multiply two irrational numbers, if we have to suppose 6 root 2 into 2 root 3, if we have to multiply two irrational numbers, we can simply multiply this and this, then 6 into 2 into root 2 into root 3, and this we can write 12 into root under root we will take 2 into 3, so this will be 12 root 6. Okay friends, similarly we can divide two irrational numbers. If you see 8 root 15 divided by 2 root 3. So what we can do, we can write 8 root 15 divided by 2 root 3, and root 15 we can break into 2, root 3 into 5 by 2 root 3. So 8 into root 3 into root 5 by 2 root 3, and this will be 4. So 4 root 5 is our answer. Okay friends. So as we have seen in the problems, and while we discussed, we came to certain facts. You can note down this. Sum or difference of a rational number and an irrational number is irrational. Sum or sum or difference we will write. Sum or difference of a rational number and irrational number is irrational. That is sum of rational and irrational number or difference of rational and irrational number is irrational. Second point, product or quotient of a non-zero rational number with an irrational number is irrational. Product or quotient of a non-zero rational number with an irrational number is irrational. Third one, if we add, subtract, multiply, or divide two irrational, the result may be rational or irrational. If we add, subtract, multiply, or divide two irrationals, the result may be rational or irrational. Okay, friends. So next we will see on a number line we have seen how to represent a decimal, a integer, okay, and even we have seen how to represent root of a positive integer or any rational number. Now if we have to represent or we have to find under root 3.5, so geometrically how we can do that or how we can represent on the number line. So if you see, we will take an example. First we will clean this. If we have to find suppose x equal to under root 3.5. So what we have to do, find, okay, x equal or x equal to 3.5, sorry, find, we have to find root 3.5. So we will consider x equal to 3.5. Now what we will do, we will make a line of length 3.5 unit, okay, 3.5 unit length. It may be, you may consider it in centimeter. Then you extend this line by 1 centimeter. It may not be to the scale as I have represented A, B, C. Then considering AC as the diameter, we will complete this semicircle. So if AB, see we have here AB equal to 3.5, BC equal to 1. So BC is equal to 1 and AB equal to 3.5. So considering AC as a diameter, we have to complete this semicircle. Suppose this one, okay, and radius will be half of AC. Radius equal to AC by 2, okay. Then we will draw a perpendicular from B that will meet the semicircle somewhere here on D, okay. This is perpendicular to AC. So draw BD perpendicular to AC. Then what will be if we consider this center as O? So we have OA. OA will be equal to AC by 2. Okay, this radius. So AC by 2 and AC we have 3.5 plus 1, so this is x. So we can represent x plus 1 by 2. This much unit. And we have OB. We can calculate OB as AB minus AO or OA. AB equal to x minus x plus 1 by 2. So it will be x minus 1 by 2. Now by Pythagoras theorem we can write, okay, by Pythagoras theorem we can write BD square equal to OD square minus OB square. If we see this triangle, okay, BD square equal to OD square minus OB square. Now we have BD square equal to what will be OD? OD is the radius, okay. So OA equal to OD, and here see OD equal to OA, and that is radius. So x plus 1 by 2 whole square minus OB square, and OB will be x minus 1 by 2 whole square. So it is equal to 4. We will take expand this, then we will get say x. So 1 by 4 we will take common, x square plus 1 minus plus 2x minus x square minus 1 minus 2x. So this x square will get cancelled, 1 will get cancelled. So we will get 4x by 4, which is equal to x. So BD square equal to x, or BD square equal to x, or we can write BD equal to root x. So geometrically we can find find under root x, or if x equal to 3.5, so we can simply find under root 3.5 using geometrical measurement. Okay friends, now we will discuss of some operations of irrational numbers. If a and b are two positive real numbers, just I will explain this. A and small b are two positive real numbers, then some identities for this is under root AB can be written as under root A under root B. Okay. Second one, under root A by B is equal to under root A divided by under root B. Third identity, under root A plus under root B into under root A minus under root B is equal to C. A plus B into A minus B will be A square minus B square, so it will be A minus B. Fourth one, under root A plus under root B, sorry, 1 we will take without root. So A plus under root B into A minus under root B it will be equal to a square minus root b whole square. So a square minus b. Next, under root a plus under root b into under root c plus under root d. It will be after multiplication. We will get ac under root ac plus under root ad plus under root bc plus under root bd using distributive properties. Next one, under root a plus under root b whole square. This will be equal to a plus 2 root a root b plus root b whole square equal to b, and this also can be written as a plus 2 under root ab plus b. So we will solve some problems. So these are identities. So using these identities we will solve some problem. So if we have to find first question, under root 3 plus under root 7 whole square, what it will be? Root 3 whole square plus 2 under root 3 into 7 plus root 7 whole square. So it will be 3 plus 2 under root 21 plus 7. So 10 plus 2 root 21. Okay. Next, if we see, we have to find under root 7 minus under root 5 and under root 7 plus under root 5. So how we can do this? See, a minus b into a plus b. It will be under root 7 whole square minus under root 5 whole square. So it will be 7 minus 5 is equal to 2. Okay. So in this way we can simplify the given numbers. Okay. Next is rationalization. Normally we rationalize the numbers in which denominators contains a root. So if there are roots or square roots or cube roots, we want to rationalize this, and we multiply by root in the denominator. Just we will see with an example. We will make the denominator into a rational number. So we will start rationalize the denominator of 1 by root 2. Okay. So how to do this? See, if we want to write 1 by root 2 as an equivalent expression and into which denominator is a rational number, so what we have to do? We have to multiply the denominator by root 2, and as we are multiplying the denominator by root 2, we have to multiply numerator by root 2 as well. Okay, so 1 by root 2 can be written as 1 by root 2 into, if we multiply denominator by root 2, then numerator also we have to multiply by root 2. So it will be root 2 by root 2 whole square, and this will be root 2 by 2. So in this way we can rationalize the denominator. Again, if we see next question, 1 by root 3 minus root 5. So in this case we have to rationalize the denominator. Okay, So how we will rationalize the denominator? Again, we will follow same thing. We will use the identity a minus under root a minus under root b into under root a plus under root b equal to a minus b. So here a is 3 and b is 5. So we will have to multiply by root 3 plus root 5, so that using identity we can free the denominator from the roots. So again numerator also we have to multiply by root 3 plus root 5. So this using identity we will get root 3 plus root 5 by root 3 whole square minus root 5 whole square. So root 3 plus root 5 by 3 minus 5. Okay. So we will get minus 1 by 2 minus 2. So it will be minus 1 by 2 into root 3 plus root 5. Okay friend. So in this way we rationalize the denominator where denominator is under root. Next we will see law of exponent for real numbers. So laws of exponent for real numbers. So what are the different laws? See, I think everyone of you know, if 17 to the power x is written, then what is x? X is called exponent. And if under root 5 is given, then this root sign is called radical. Okay, so exponent and radical. So what are the law of exponent and radical? If a and b are two real numbers and m, suppose a and b are two real numbers and m and n are exponents, then as per law of exponents we can write a to the power m into a to the power n. Okay, so a to the power m, what is this? A to the power m plus n. That is, exponents are added when base is same. A is our base. A is called A is base. Okay, when base are same, then we simply add the exponents. Second one, a to the power m and whole to the power n can be written as a to the power m into n. Third law is a to the power m divided by a to the power n is equal to a to the power m minus n. Okay, and this will be positive when m is greater than n. Fourth law is a to the power m into b to the power m. It can be written as ab to the power m, that is product of two numbers and whole to the power n. So based on this we will do some problems. So let's clean this. Just remember this, a to the power m into a to the power n equal to a to the power m plus n. A to the power m whole to the power n equal to a to the power mn, and simply when it is divided a to the power m divided by a to the power n equal to a to the power m minus n. Okay, so we will clean this, and then we can write how if we have 13 to the power 1 by 5 into 17 to the power 1 by 5. So as per the law of exponents, we know a to the power m and b to the power m equal to ab to the power m. So 13 into 17 to the power 1 by 5. Okay friends. So in this way we can write. Next, if you see 23 to the power minus 10 by 23 to the power 7. So a to the power m by a to the power n. So this we can write as 23 to the power minus 10 minus 7 is equal to 23 to the power minus 17. Okay. So if we have a greater than 0 and m and n be integers such that m and n have no common factors. So e to the power m by n. Okay, this can be written as under root a nth root of a to the power m, or we can also write this as nth root of a to the power m. Okay. Similarly, if we take few examples, if a is greater than 0 and p and q are rational numbers, a is greater than 0, p and q are rational numbers. So in this case, these are similar to law of exponents, just this is extended to your rational numbers only. A to the power p into a to the power q equal to a to the power p plus q. Second one, a to the power p whole to the power q to a to the power pq. Third one, a to the power p divided by a to the power q or a to the power p minus q. And fourth one is a to the power p into b to the power p equal to ab to the power p. Okay, so if we take a problem, just see this 2 to the power 3 by 2 into 2 to the power 1 by 3. Now as base is same, so we can add these two rational numbers 3 by 2 plus 1 by 3. Okay, so it will be equal to 2 to the power 3 by 3 is equal to 2 to the power 1 equal to 2. Similarly, if we have another problem 7 to the power 1 by 5 by 7 to the power 1 by 3. So it can be written as 7 to the power 1 by 5 minus 1 by 3 equal to 7 to the power 3 minus 5 by 15 equal to 7 to the power minus 2 by 15. So in this way, we can solve problems related to exponents and radicals. Okay friends, so I hope all of you have understood this lecture. If you have any doubt, please let me know and you write your doubts in the comment box. I will try to resolve your doubts. Okay friends? And if you like the lecture, please like our video and subscribe our channel Aha Jindagi Edu-Campus. Also press bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.